Okay, hi everyone. So for this video, I'll discuss the displacement analysis with the focus on the analytical approach, no, for solving, for example, the maximum swing angle of a four-bar mechanism, no, to be specific, let's say a slider, crank and rocker mechanism. And also for slider crank, we can also find the length of stroke and also the quick return ratio. So let's begin first with the definition of displacement analysis. So we've discussed before that we are interested with the relative motion of our mechanism. And in this displacement analysis, we can determine the relative position of our mechanism. And hopefully, we can also know the limitations of our mechanism. We can determine what are the constraints, no? What is the maximum angle that can be obtained, the maximum stroke, for example. Now, there are two ways to determine this limitations. No? We can do this graphically or analytically. But I will focus for now on the analytical approach so that we can get the exact value of the relative positions. Now, let's say, for example, you want to find the maximum swing angle of this four-bar mechanism. So as you can see, we can assume that this is a Grashof condition four-bar mechanism since it can rotate, so the link AB can fully rotate while C is or C can rock, no? So what we can find is this maximum swing angle of CD, no? And that could be an important thing for designing our machine. So to determine the max swing angle, the the best thing to know is what will be this extreme positions C prime, and then the other one will be this point, right? So we can start with this C prime for now. So if you can imagine, if you rotate this in a counterclockwise direction, you can obtain this configuration. So you can imagine if you rotate this into this, so what happens is this becomes AB, no, this is still AB, and then the member BC will be this full one, no? So the first clue in finding the maximum angle of a forward mechanism is to determine what time will the crank and the connecting rod to become coincidental, meaning magkapatong, no? So in this case, link AB and BC are coincidental with each other to show you that this will be the extreme position, no? And then what we can do, no, so to find this angle right here, no? So to find this angle right here, we also want to determine this other extreme position. And as you can imagine, no, you can imagine that this will be your configuration, no? So meaning this will be AB, sorry, this should be AB, sorry. This should be AB and this should be BC. So for the other extreme position, it is usually you have this crank and connecting rod that is straightened out, no? That will be the other extreme position. So you can call this C double prime, no? As sorry. Yes, this is the C double prime as the secondary configuration or the secondary position that is at the extreme position. So I'll just raise this. Yeah. So again, we can find this maximum swing angle as long as we can find the relative angles between these two. Now, let's say we have this scenario wherein we have everything given, no, the lengths of the four-bar mechanism, then we can probably find the maximum swing angle, no? So I hope you've already known how to do this graphically, no? But we will do this analytically. So you can imagine, we can check first if this satisfies the Grashof condition, which basically means that this crank AB can fully rotate. So as you can see, this is the Grashof condition, no? So Grashof condition is true. Therefore, you can start solving already for the maximum angle. So what you can do is again find first the extreme position C prime, and then what is the relative angle, no? So to be able to find the maximum swing angle, which is this theta max, we can determine first, no? Sorry. We can determine first this angle relative to this configuration. So you can find, let's say this is theta d prime, no? So if you can imagine, if you want to find that portion, no, so theta d prime, then what happens is we can find this angle actually, since we have the sides of this triangle given, no, and we can find this angle. If we can find this angle, we can also find this angle. So let me explain that in detail. So you have this configuration right here, and you have this triangle, as you can see. So this will be C prime, this will be point A, and then this will be point B. So the CA here, as you can imagine, will be the difference between BC and AB, no, as you can see. So to get AC, you can subtract this and this one. So the length of CD or BC and AB, where's sorry, oh, where's that? Where's the length? So we have 25 centimeters and 60. So you have 60 minus 25. So basically this is 35, right? 35 centimeters. And then for CD, so CD is already given, which is 45 centimeters. And then for AD, it is also given as 50 centimeters. So we have this 50 centimeters. Now we want to really find this angle right here, which is theta D prime. And what we have here, no, or in relative to this angle right here. So since we know that this will be a full 180 degrees, right? So we can say that this is 180 degrees minus theta prime D, no? So how do we solve for this now? We can imagine we can use the cosine law, no? So the cosine law basically means you have c squared is equal to a squared plus b squared minus 2ab cosine capital C. So if you have a given three sides, no, so A, B, and C, and then you can find the angle C, which is the opposite of this side, no? So as you can see, the opposite side here is 35 since we are trying to find this angle, no? So we can write this down directly, no? So we have 35 centimeters squared equal to, you can use 45 squared plus 50 squared minus 2 times 45 and 50. And then you have cosine C. So the angle here, C, is 180 degrees. 180 degrees minus theta D prime. So to solve for theta here, let me just rearrange this equation. So you have 45 squared plus 50 squared, and then divide, minus 35 squared, divide this by 2 times 45 and 50. And then you can use inverse cosine or arc cosine, and then 180 degree minus that to find this angle. So sorry, this will be shortcut already, but you can solve this on your own. So solving for theta, that will be equal to, you have 180 minus arc cosine, 45 squared plus 50 squared minus 35 squared all over 2 times 45 times 50. So the answer should be 137, no? So what theta D is 137.17 degrees. So this will be the angle 137.17 degrees. So now we can also find the angle at this portion, no? So if we let's say this is angle theta D double prime, so that if we deduct this by the theta D prime, we will get the maximum swing angle. So let me do that again. So in this case, as you can see, we can form another triangle and we can, the sides of this triangle are all defined. We can find the angle here, which is also relative to this angle. So again, writing this down, you have here A, C, double prime, and then B. So the A to C here, so this will be just AB plus BC, no? So this is 25 plus 60, no? That will be 85 centimeters. And then you have CD, so CD is, what is CD? So 45 and then 50, sorry. So this is 45 and this is 50. So we want to find again this angle here. So theta D double prime. And in relative to this angle, so the total angle here, as you can see, this is a straight or supplemental angles. So this will be 180 degrees again minus theta D double prime. So again, we can use the cosine law. So you have 85 squared is equal to 45 squared plus 50 squared. Okay. And then minus 2 times 45 and 50, and then cosine 180 degrees minus theta d double prime. So we can solve that again. So I've already solved this one. So similar to this, we have 180 degrees minus our cosine, and then 45 squared plus 50 squared minus 85 squared all over 2 times 45, 50, and 50. Okay. So the angle right here, I think I can just change this one. So this will be just 85. So the answer should be 53.13. So the angle here is 53.13 degrees. Okay. So now, again, we've already determined this angle in this angle right here, right? So therefore, the maximum swing angle is just the difference between these two. As you can see, this is just the difference between the two. So this will be their difference. So we have 137.13, am I right? 137.17. 0.17, where is it? 17 degrees minus 53.13 degrees. You will get this maximum angle of this is 84.04. Yan. Okay. So you will find this answer as your analytical solution. Now, if you do this graphically, so meaning you can use your ruler and protractor and you can measure the angle in between, and you will still find around 84 degrees depending on how accurate have you drawn the 4-bar mechanism. Okay, so that's all. Thank you.